Hello and welcome to the Learn Clang Rock Paper Scissors Screencast. This is episode 8 and today we will be converting these structs into C++ classes and have a look at access permissions in the process of this. If you remember one of the last episodes, I've mentioned many times that structs are really just like classes but with the access permissions set to public. And also I wasn't sure initially if this kind of public by default policy, if this carries through to inheritance, but it does. And what this means we will learn in a moment. For now I will just kind of with all my ignorance, convert a struct into a class and assume that it will just be as before. That's really it. And we will try to compile this right away. Let's see what happens. All right. Say you lost is a private member of RPSItem. Okay, let's review this. So we have RPSItem pointers here, and we try to call this function, this method, say you lost. And what happens is that it now, all of a sudden, all we did was changing structs to classes. So what happened? All of a sudden it says it's private? What? Implicitly declared here. Oh wait, sorry, that is not what I wanted to click. That one. Implicitly declared here. Well, it's really good, this message, because it's indeed implicitly declared private, because the default how do you say it? The default access permission in classes is indeed private. So C++ knows 3 access permissions. I will just type them down here. Private, protected, and public. And that's it. So private means that only you, as the type itself, can use the respective member or method. Protected means that only you, as a type, can use your, it's the same as private basically, but also your direct subtype or subclass is allowed to use your protected methods, by the way. So if a method is protected, it may also be used by your subtype. If your method is private, it's really just you as a type who defines or declares that is able to use it. And public means that everybody, even outsiders, especially outsiders, can use the respective method. So public is something you want to declare on your API methods or interface methods. This is something that others can call, whereas everything that is internal to you should be private or protected. And that depends on what you plan. You can say, well, it's private. Not even subtypes may use this special method of mine because it's so kind of maybe hardwired to or makes assumptions that I don't want to impose on anybody, and this is why you would possibly want to make something private. And in classes that's the default. This is why now we are unable to call this method, which is our interface method. And it happens that's the only interface method that we have. And we have constructors here. If these are private, then you're actually not able to construct such an item yourself. Even that seems to be not an issue here. That can be useful, But for now, I would just like to get back to the state that we had before, which means that we are actually able to use this. Say you lost method. So to do this, all we have to do is put in a public colon here. So that syntax means that everything that follows below will be public, so everybody can use it. And I could even go as far and declare my constructors as private, maybe. Does that work? Let's see. Calling private constructor. Private doesn't work because if we look at our inheritance, the rock constructor is calling the RPSItem constructor, which is now private, and this doesn't actually work because even the subtype does not have allowance to call this constructor anymore. That's, as I said, a great way to prevent your class to be instanced directly, basically. So if you make it protected, all of a sudden, well, this, it's interesting now because I made it protected and it still tells me the same thing. And you could ask yourself, why? I just fixed it. But there's one more thing that has to be looked at very precisely. It's the class inheritance here. So our rock is now inheriting an RPSItem, but the default inheritance policy is private as well. Previously it was public, we remember that. So this is the same as saying private RPSItem. So that's why it doesn't work. If we would say, let's try it. If we would say protected, let's see if that works. It doesn't work because protected really just reduces the access permissions by 1. So if you inherit a type in a protected fashion, then the type's public methods will become protected, and protected methods will become private. It's just all -1. And private methods, they remain private because they can't go any lower, basically. So this is what that means. This is one. I mean, if you inherit in a protected fashion, then what you really want to say is, I don't want to inherit the interface of my base class here. I want to have my own interface and not bother. I will use this thing kind of internally, and this is really what that says. So what you have to do to make this work is public. So now the rock should at least be a non-issue anymore, and God, I shall be damn it, it is still an issue. Of course I'm silly and stupid, because of course the constructor of my rock is still private, So nobody can call it unless you're the rock yourself. So how does that even work, you could ask? Well, you could have a public, well, not new, but make rock function here, or method, that will then call the constructor, initialize a rock somehow and return a pointer to it, or a copy. This is how you can actually instantiate a type with private constructors at all. This can be useful basically if you, well, basically just if you want to force people to use your method. This can be useful if you, well, I can't really make up a case yet where this would be useful, but I've used this myself on some occasions, and I wonder which occasions these have been years ago. So let's make this public as well, because we want to instantiate it, and let's see what happens now. Good. So now it's paper and scissors who have trouble, and I wonder if that would work now. It shouldn't work still. Now, oh wait, that does work. So protected remains protected. No, paper rock. Here, cannot cast rock to its protected base class. That is interesting. So that is interesting. I didn't know that, for instance. So you can call the constructor apparently, but you can't cast it to a protected base anymore. That's awesome. So you can control casting like that as well. Man, cool. So most of the time you are obviously inheriting in a public fashion, and we shall do this here as well. And let's see what else there is. Oh yeah, true. Now we have to declare our constructors public, like so. And now it's all back to normal. So all this additional typing we basically had to do just because we converted from structs to classes, which is something worth noting. What does this mean? I leave it as protected. This means that no one is able, I mean, you know, I can't create an RPS item myself, for instance. This is not allowed anymore. Which can be useful, you know, if you just say RPS item is the base class and it should never be instantiated, then you make its constructors protected. You know, so let's try that. RPS item test. Does that work? No. It is an abstract class. Okay, this doesn't work for many reasons actually, but it's good that we see the error message here. Variable type RPS item is an abstract class, and abstract classes cannot be instantiated directly. Abstract classes are all those that have at least one pure virtual method, and pure virtual methods, we remember, are these guys. They say, okay, I'm a virtual method and I'm assigned kind of a null pointer here. This means that subtypes have to and are forced to implement this method. If they don't do this, they're abstract themselves and cannot be directly instantiated. If I would remove this, I would get the next error, which is what I anticipated, calling a protected constructor of class RPS item. You know, this is protected. No one can call it unless you are a subtype. Oh, that one. That makes sense. And you know, if that would work, by the way, if I would make it public, then the linker would say, well, would the linker say anything? Yes, it would say something, because it tells us that basically this function here, it wants to put the definition of this function for RPS item into the vtable, blah 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 blah. You know what a vtable is? Basically makes this whole class inheritance and virtual method thing work, and it wants to sign it but couldn't find the defined symbol because we didn't define it, and that is a problem here. So now we have a link time error basically because it's not defined. If we would define it like so, it's kind of underlined because we don't need a colon here in this case. Now it actually does work, as you can see, because I've defined my method here. But let's keep it as it was. Should be pure virtual. That should be protected, just to remind us of what this actually means. Could be private, but that doesn't make too much sense in a if this is supposed to be a base type. And that should still compile if and only if we don't try to instantiate an RPS item. One more thing I want to show here, and then I guess we are done with that, is just to remind you, if you come from Python, this looks pretty much like a class member, right? Because you put it kind of into the belly of the type itself. But that's not the case here. That's indeed a declaration of an instance member. So you have to declare your instance members in advance in C++. And that's really something important to notice. If you want to have I mean, it's not the same as in Python ever, but if you want to have class members, then, or class methods, it's not really a class method, then you can define them static, you know, static int RPS class member, and you have to initialize it right away, by the way, like so, and it needs to be constant, of course. So you know, there are lots of limitations for class members, which are actual data types. You can do the same thing with methods, but in that case, I can tell you that you will not have any class level virtual functions or something like that. That only works with instances. It's really relatively limited. In Python, that is much more powerful in a way. So yeah, static methods would be useful, for instance, if you want to have some sort of creator, something that returns a pointer to one of your items. So this is one way to control instantiation of your type. If you only want your type to exist, for instance, as a pointer, then you would make your then you would make your constructors protected, and then you have a static RPSItem pointer creator that will return one of your items, and this guy internally can just use the protected constructor here, because we are still a member or part of the RPSItem itself, right? So this is why that would work. So that is that. That was a quick overview of access permissions in C++ classes. I hope it was informative and you learned something, and I will have to figure out what I want to talk about next time. Until then, have a good day and thanks for watching.